Hello and welcome to the Weekly Space Hangout for Wednesday, April 17th, 2019. I'm Fraser Kane, publisher of Universe Today. This week, we are going to be talking about Pepsi not destroying the night sky. Thanks, Pepsi. NASA's twin study report released, what happened last week with Bearsheet, Exoplanet Updates, and the Falcon Heavy success and then sadness.
Boink.
Sploosh. Joining me this week, we've got Dr. Morgan Rambert. Morgan.
Hey, Fraser. It was a big week, and now we get to unpack it.
We don't have Paul this week, but you can definitely confirm that Paul exists.
I did. I saw Paul this week with my very own eyes, and it was glorious.
That's right on. And you guys had some tasty barbecue, and he gave a big talk to your group. Also this week, we've got Dr. Kimberly Cartier. Kimberly.
Hey, Fraser, happy podcast day.
Yay! She said the words.
I said the words. I missed out on them last week. Morgan stole them, but they're back.
Good. All right. Now, before we get into our special guest and the news this week, I just want to give a big shout out, of course, as always, to our good friends at the Weekly Space Hangout crew. They are, of course, the producers. They are the guest wranglers. They are our biggest fans and our biggest assistants as well. So we really could do the show without them. And a huge thank you to everyone of the Weekly Space Hangout crew. If you want to be a member of this amazing community, totally free, just go to wshcrew.space. They will welcome you with open arms and put you to work making this show better, however you want. It's up to you. You're an executive producer now. So go to wshcrew.space. All right, let's get into this week's special guest, Dr. Dorothy Oehler. Dr. Oehler, welcome to the Weekly Space Hangout.
Really nice to be here.
Who are you? What do you do?
I'm a geologist. I have been working in planetary science since about 2003. From about 2003 to 2017, I was at Johnson Space Center. And then after that, I joined the Planetary Science Institute. But before 2003, I had a long career in the petroleum industry. And ironically, I studied methane for most of that career. We had a big project in my research group at Conoco, which is where I worked, on methane seepage. We thought we might be able to find major reserves in the subsurface by surface seeps. And that project went on for some 7 years, and we looked at methane in all sorts of settings all over the world, but subsurface sources of methane. So we learned how it formed, where it got trapped, how it moved in the subsurface. So we have a lot of experience in that. And then after that, I spent some years in the London office of Conoco in the exploration side of things. And ironically, I was working on methane again because I was working on the gas fields of the Southern North Sea. So it's kind of funny, but one of the first projects I worked on had to do with methane seepage. And here I am many years later doing that again, or thinking about methane again, but this time on Mars.
That's great. And, you know, we were talking about this before the show, that we went into this quite a bit last week on the show about the state of methane on Mars, you know, as a potential biosignature, very exciting possibility that there could be life on Mars. Curiosity made this great detection of methane all around it. A couple of weeks ago, we got an announcement that that ExoMars confirmed it. Where are we in the state of methane on Mars right now?
Okay, well, I was part of that. I was a co-author of that article that feels like we have confirmed one of the Curiosity measurements of not just the background variation, but one of the spikes. They measured several spikes through the years. And that is a paper by a group of Italians and Belgians, mainly. They've been tracking with the planetary Fourier spectrometer on Mars Express, but tracking in a different way than was done previously. They use a spot tracking method where they stay focused on an area instead of that nadir mode of observation. Gives them a much better signal to noise ratio. And they had some enhancements in their processing, which I don't understand. But the data are enhanced from what was acquired in the early 2000s that a lot of people sort of had some doubts about. And when looking at that data, they noticed that there was one very definite spike, one sol after Curiosity reported a spike in June of 2016. So unless you believe it's a coincidence, it seems like you have two totally different types of instruments, one on the ground and one from orbit, detecting the same thing. It's hard to believe it is a coincidence. So it feels like it's a confirmation of the fact that there may well be some spikes in methane there. Even though in the past, I think there's been a lot of doubt about many of the previous measurements. And so this is important to come at this time. On top of that, we took that a little bit further. There was a group of modelers, climate modelers in that study, and they tried to use the current views of the Martian climate, the time of year that spike occurred, to see where that methane could have come from, and still agree with both the Curiosity detection and the detection from Mars Express. They concluded initially that the seep couldn't come from any further away than about 700 kilometers in any direction from Gale Crater. So they made a grid over that 700 kilometer area in all directions, and did literally millions of iterations of climate models to see which part of those grids could be the most likely to have sourced the methane. Let me show you this figure. Okay, you've got my figure up there.
Yeah.
You can see Gale Crater, and the yellow triangle is the location of the Curiosity rover. The grid, the black grid in the area is the grid that they came up with to assess. Somewhere in there, it seemed like the most likely place from which the Curiosity and the PFS detection could have come. When they finished their modeling, they came up with 3 blocks that were much higher in probability than any of the others. And they were 3 in the east and northeast sectors. I don't know if you can see the block names, but one of them was E8 and one was East Southeast, and the other I think was EE Southeast. But E8 and East Southeast were among the most important. I was part of a small geological group, myself and my Italian colleague, Giuseppe Etiopi, and we independently looked at the area of that grid to try and predict where methane might seep from, given the geology. And if you want to put that figure back on again.
Oh, sure.
Can you do it? I'll
Yeah.
just show you a few things about the geology that will make it more understandable. Okay, so this is what you see, the map. The coloring is topography, with reds being the highest and blues being the lowest. And you can see that Gale Crater is on the dichotomy, the boundary between the southern highlands and the northern lowlands. That dichotomy is covered with faults. Many people think the dichotomy was formed by a huge impact way in the past. If so, it would be the location of many very old and very deep-seated faults. And you can see that some of these have been mapped. If you can see that area that says Aeolus Mensa, and then there are some faults there. There's both extensional and compressional faults in the area. The 2 colors are extensional and compressional. But you can see along the dichotomy is where those faults seem to be concentrated. Just looking at this map and knowing that most of the methane seepage on Earth occurs through fractures and faults, you would pick out the fractured area. But on top of that, we also know that methane, if it's produced in the subsurface, has to be trapped. It migrates through faults and fractures, and if there's no way to stop it from migrating, it will be lost, particularly if it was formed way in the past. So from Earth, we know that some of the best seals that can trap methane in the subsurface are permafrost and salt. We don't have a lot of salt on Mars, but we certainly have a lot of permafrost. And there was a recent paper by Wilson and others that reassessed some of the data from the neutron spectrometer on Mars Odyssey. And they concluded that there was an area of high enough water equivalent hydrogen to suggest that there was bulk ice in that equatorial location, and that is just essentially adjacent to those
Right.
blocks that I had mentioned.
All
You're
right.
just gonna, can you hear me?
Yeah, I can hear
Oh,
you. No problem. Yeah.
so in any case, we picked the blocks based on geology, the faults and the proximity to ice that could trap methane, so it would accumulate.
Yeah.
And even beyond that, we saw that some of those faults extended into the region of ice and looked like they showed very, very recent offsets.
So I have a million questions. I mean, I guess like just to start with, just to get an understanding here, like the detections that ExoMars did of methane in that region, like, did it see other blobs of methane across the entire planet? Like, is it mapping very comprehensively and then just found this one blob across the whole planet that happened to be where Curiosity is?
They were focusing on Gale Crater
Specifically.
because they knew that Curiosity would be trying to observe methane. So they focus on the Gale Crater region.
Okay.
And on that figure, if you remember, there was that black sort of oval. That was the envelope of the PFS detections in that area.
Right. Okay. So they were specifically mapping as carefully as they could the area where Curiosity was to try and to confirm at the same time that Curiosity. But I guess the detection by Curiosity was a bit of a surprise. And so back to the coincidence thing, was ExoMars sort of continuously mapping, or just when it was doing a pass they knew to map this area?
No, I think it was actually observing that region for a year and a half, close to 2 years. And then they went back and looked over the data. So no, they didn't just happen to do it when Curiosity noticed the spike.
Right.
And the interesting thing is that, except for that spike, within that year and a half period, they had no other detections of elevated methane above so-called background.
Yeah.
So, and they are currently looking at other areas now, areas that we've given them. We've given them a list of potential areas. So they are kind of focusing on some of these other areas as well. We don't have any data back yet, but they are looking at a few other areas.
Yeah. So I mean, the question that everybody has is like, what's causing it? Both answers are interesting. If it's biological, of course, it's one of the greatest discoveries in the history of modern science. If it's volcanism, that is also interesting because that means that Mars is still somewhat active. Do we have any sense which way this is leaning yet?
It could be biological, but there is no evidence, no convincing evidence at all yet for that. So is there any evidence for abiotic methane? And the answer to that is yes. There are several processes by which abiotic methane can be produced by chemical processes that have nothing to do with life.
Right.
Some of those things happen on Earth. There are springs that emit what's generally believed to be abiotic methane, where the methane is produced by a Fischer-Tropsch type chemical reaction between CO2 and a source of hydrogen. That hydrogen on Mars is thought to come from serpentinization. That process you've probably heard of, which is essentially the hydration of olivine produces hydrogen. It's thought to have been a very major source of hydrogen on Mars, particularly early in its history.
But I think the part that was so compelling that got people so excited was that it happened during springtime on Mars, the time that you might expect here on Earth to see a bloom in methane production.
Let me just stop that for a minute.
Sure. It's it's a time of the year here on Earth when life starts to grow, and so you might think that feels like a coincidence.
Yeah, and the seasonality that Webster and others have reported, does appear to have something to do with spring, but there are a lot of things that influence seepage on Earth, and that one of the papers that I wrote or was a co-author with address that. And a lot of things on Earth are seasonal as well. Temperature changes seasonally, faults move, pressure regimes change. You can get pressure when storms come through. Pressures can be lowered just by high winds, and you get a little exhalation of methane seepage just in situations like that. So a lot of things can even be seasonal and still not necessarily be biological. And I should say, but even if the methane is not biological, many types of organisms don't produce methane, and other types of organisms use methane. So it doesn't cancel out the idea of possible life on Mars,
Right.
even if the methane is not produced by.
So then what would it take, right? What would it take to be able to distinguish between the two?
I think really, I mean, what we tried to do was to identify a likely source area on the ground where methane could be originating from the subsurface. The next step then would be to have a lander in that area and actually collecting methane at the surface, where you would get a much greater concentration, and you can look in detail at isotopic composition and for other molecules that might be associated with it that would help you to understand the origin of that methane, whether it was biological or not.
So there's just like with the tools that we have at our disposal today, both with Curiosity where it is right now and with the ExoMars orbiter, you just can't, you don't have the sensitivity to figure out, like you need to literally find those vents and sample from the source.
Yeah, yes, you do. Even on Earth, you would have to do that. Honestly, I mean, even if on Earth, for instance, way back when I studied this idea with Conoco, that maybe a methane seep on the surface would tell us that there's methane at depth in a reservoir, several trillion cubic feet, for instance. And we discovered that you could barely detect methane seepage a meter above the ground when you knew it was seeping. And we actually had samples of it at maybe 5 and 10 feet below the surface that had seeped there from a reservoir at 3,000 feet. So we knew there was seepage, but it gets diluted so quickly in the atmosphere and dispersed that you just don't get enough.
Okay, so then you get some of our sweet Weekly Space Hangout budget to design a lander. What kinds of science experiments would this lander? What kind of profile would it have, and what would you want it to do, and where would it go to get to the bottom of this?
Well, you would collect gas right at the surface, but you might also want to drill a shallow core hole. You would want to look at the lithologies, see if there really was permafrost down, because some people don't even believe there's permafrost in equatorial latitudes, shallow permafrost. So you'd want to look at the lithologies. You would collect samples and put them in cans to trap the gases coming out of those. So you'd have canned samples all the way down the hole. And then you could do mineralogy on the samples. You could do a full suite geochemical analysis, which is what we used to actually do in Conoco when we were trying to understand if the methane that we found there was actually from that reservoir that we knew that was at depth, because we started off with a known quantity. We knew there was a reservoir depth.
And it wasn't just from the nearby cow pastures.
Exactly.
Yeah.
And we were able to do that. We did water analyses, we did everything. But the main things that were really telling were the isotopic analyses of the methane and the ratio of methane to ethane. And usually methane is like 98, 99% in a natural gas deposit. But some of those ratios were important as well.
But if someone gave you a bottle of methane and said, did this come from volcanoes, or did this come from olivine, or did this come from cows, it would actually be a very difficult thing to tell the difference.
I don't do that. Yeah.
Really? Wow. That's interesting.
Because you want to see if you think the methane is biologically produced or even abiologically produced, you have to look at the oxidized sources of carbon from which it came and look at the difference then to look at the amount of fractionation, whether it was biological or more like this chemical process. So you have to look at the whole picture.
Yeah.
So it's a difficult question. It's not really easy.
Yeah, it's interesting to me because I think in my mind I had sort of oversimplified, as I classically do, just that it would be just a matter of being able to really measure it very well with the right machine, and then that would give you the answer. But it really sounds like you need to find the source, be it melting permafrost, or be it some reservoir of water that has some kind of bacteria underneath, or if it is actually some kind of volcanic vent that you can track it back to to the process. So it actually sounds like this is going to be a mystery for a long time.
It is. It is. We hope that, down the line, the PFS or maybe TGO will detect some spikes in methane here and there, and there'll be more work, more modeling, and geologic analysis to help locate the source on the ground, and those places then will be places for future landed missions.
Right.
Yes, it probably will be a long time. But
Yeah.
the other thing you could do, I didn't mention this, but you could have a nice microscope there, and you could actually look for evidence of life.
Yeah, well, I mean, Mars 2020 is going to try to do something kind of like that, but I'm sort of imagining a different mission profile, some kind of drilling nose that just keeps sniffing up, looking upwind to try and find the source of where the methane is coming from, and then drill, which is sort of a different creature. So we'll definitely sort of fast track the budget for that rover. I'll get back to you. Dr. Oehler, where can people find out more about what you're working on?
These papers have been recently published. The one on the PFS data is Girana et al. I think that one is actually shown in the lower left of the figure, but it's in Nature Geoscience.
Perfect.
It's available right now ahead of print. And the other paper I had was, sorry, my computer went off. No, my desktop computer, it was giving us the light.
Yeah, it was giving you the lighting, yeah.
The other paper, I have a long paper by Oehler, myself, and my colleague Giuseppe Idiope. So it's Oehler and Idiope in Astrobiology, 2017. It's open access, and it describes all the different kinds of processes that can form methane. And it talked about different areas on Mars, places that might be good places where methane could be generated and trapped. And we have a table of selected areas. So that would be a good paper just for
Wonderful.
background.
Well, thank you so much for taking the time to chat with us and clear this up. I really appreciate it, and I know the people watching as well. This is a topic that comes up over and over again. It was great to get somebody actually working on the mystery to remind us that it is in fact a really big mystery.
It is.
Yeah. All right. Thank you so much.
Thank you very much. Nice talking to you.
All right. Let's move on to the space news. Morgan, what have you got for us?
You want the cool news or the not cool news?
The cool news.
All right. Well, year ago, NASA twin study. We sent one twin to space. I can never remember if it's Mark or Scott. The other one stayed. Scott. The other one stayed on Earth. NASA subjected both to regular physical exams, collected bodily fluids, had them go through various activities, take cognitive tests, all sorts of things to try to understand once and for all whether humans or how human bodies react to long duration spaceflight. This was a test that lasted basically a year. And I think that he's the American that spent the longest in space at one consecutive time. And now they've crunched all the data together, and a year later we have the results of that. And the answer is that the human body is affected by space, more so in some ways than you might expect, less so in others. And all of this comes with the big caveat that this was one person in space one time with one twin. And I think none of us would particularly like all of humanity to be generalized from ourselves. And so we should keep that in mind when we think about the results of this. And a lot of this report focused on doing gene sequencing and DNA sequencing of the blood and to see what happened to our DNA when we're exposed to all of that radiation in space. And the answer is, it wasn't great. So the body has something like 20,000 genes that sort of make up who we are on a chemical basis. And of those, they found as many as 500 of those genes changed over the course of the year. And 25% of those changes seem to be permanent, in that when he came back to Earth and they kept doing more tests, 75% of the genes eventually reverted back to what we would expect for a normal human, but a quarter of them stayed the same. And maybe even more concerningly is that as time went on in space, more and more genes were being changed. So at a year end, at the end of the study, about twice as many genes had changed as 6 months in. And so that suggests that had he been there 2 years or 3 years or 4 years, that more and more of those genes would have been changed. And maybe one of the most surprising pieces of information from this study was that when they got him back to Earth and they kept taking blood tests and doing sequencing for another few months afterwards, and they found that some genes were continuing to be damaged and to change. And you'd think now that he was back within the Earth's magnetic field that really you wouldn't have more change than the normal background level, but they found a higher level of change, and we don't really understand why. Like, what is the mechanism that's causing the DNA to continue to change after he comes back?
Do they think that one of the changes that one of those permanent changes that could have happened in his gene sequence was his susceptibility to having gene mutations back on Earth?
The trouble with genes is that we don't really understand them. Right,
Fair.
we can link
with everything. We don't really understand it.
Yeah, we can link individual genes to things happening, but we don't really know why in most cases that's happening. And in most aspects of human life, we don't really yet know what gene or if genes at all control those particular things. There was one other interesting thing that the study showed, which is that for many astronauts, it's been seen that they have that they sort of get a little dumber in space. Basically, that their cognitive ability is reduced a little bit. They don't remember things as well. They don't think as quickly when they're in space, and then they come back to Earth, and that goes back to normal. But for Scott, the reverse was true. Cognitive tests showed that in space, he actually was faster at the cognitive tests than he was before he left. But then maybe a little concerningly, when he got back to Earth, he was slower, both from when he was in space, but also compared to the baselines before he left. And that suggested that the transition back to life on Earth had taken, a small but measurable toll on his cognitive ability. And again, we sort of need to know, is this like a fixed effect? Or if he was in space for 2 years or 3 years, would that diminishment be even greater? And that's why we need to keep doing this with more and more subjects over long periods of time. And I'll throw in here that NASA just announced that one of the astronauts currently on board the space station, who was originally supposed to come back in September, will now be staying, I think, through February, which will mean that she'll have also been in space for about a year. And although she doesn't have a twin on Earth to compare it to, it does extend again this baseline, and it'll give us n equals 2 for people who have spent about a year in space to see how their genome is changing and how their cognitive abilities are changing and things like that.
Well, and I mean, the Russians have a bunch of people who have been in space for that length of time. So,
absolutely. It's just not in this sort of modern era of being able to do all of these advanced medical tests.
So Nancy was mentioning in the comments that Dr. Susan Bailey, co-author of NASA's twin experiment with Mark and Scott Kelly, will be our guest on May 22nd. So we will get a chance.
Oh, okay. Let's not even talk about this too much then.
Well, then you're just setting it up to pose the interesting questions. I mean, the problem with this is that, as you said, people don't really even understand how any of it works. And the problem was you saw a lot of people just with off-the-cuff, bad journalism shortly when the first twin study was released and this more recent one, just like saying, speculating wildly on how, turned him into some kind of space monster. So it's really hard to know what is the real outcome. Is space going to kill us? And which parts of it? Is it the radiation? Is it the gravity? I mean, I think that's the next step, is to start to try and tease out the variables and figure out which thing is causing what effect on the human body so that we can start to minimize it or figure out if we're okay with it.
Yeah, well, that's the trouble with damage to the DNA. We've known for a long time that gravity has a lot of lack of gravity has a lot of adverse effects on our body, but we've learned to minimize most of those by changing the way that astronauts eat and the way they consume fluids and the way that they exercise. We know how to manage sort of macroscopic physical changes like that. And I think we can say with some certainty that if we sent astronauts on a 3-year trip back and forth to Mars, that they would remain healthy in the sense of having muscle mass and workable digestion and all of that kind of thing. We don't know how to protect DNA. If we did, all of us would probably be living a lot longer and a lot healthier than we are. And so I would say that there's a pretty big sort of flashing message here that space is bad for your DNA and that more space is more bad. And what we don't know yet, and the only way to know this will be to sort of have human guinea pigs doing it, is there a sort of a limit beyond which more space does not get more bad and you've kind of accumulated the full amount of bad. And the only way to know that is for people to just keep doing this in longer and longer periods of time. But that's kind of a scary proposition because it could be that until we sort of crack the question of how to protect our DNA, in our normal everyday lives here on Earth, that we can't really safely and in good conscience send astronauts on long duration space missions to a lunar base or to Mars or even just to hang out for years on the ISS.
Well, I mean, Mars is like a 3-year plus turnaround if you want to spend any significant time on the surface. So even just getting there with the fastest ways that we know how is a 9-month plus trip. So this is a serious question that we need to answer. And I think if we do this safely, then we're looking at decades of study to tease out those variables and to try the different methods to figure out which ones we can mitigate through rotation, through radiation shielding, through, I don't know, flamethrowers.
Yeah, I think it's going to have to be mitigation because this is one of those situations where sort of the needs of spaceflight are not leading the impetus for trying to figure out how to protect DNA. If we'd never gone to space, we hopefully have figured out how to protect our DNA just as fast because it affects every one of us. And so NASA's special attention, I don't think, is going to particularly advance the science because this is like a $1 trillion industry if you can figure out how to revitalize DNA.
Yeah.
And so what NASA can do is to try to stop the damage from happening. And that's the realm that we can work in to figure out how to shield the astronauts if radiation is really the main cause.
Well, congratulations. You've got a new meme. Space is bad. More space is more bad.
All right. I'll take it.
Kimberly, what have you got?
So last week we were all excited, or maybe I was the most excited of all of us, for the Israeli lander Bereshit is going to land on the moon. I was watching with bated breath while the landing was occurring last Thursday, and by now I'm sure all of you have heard that it was not a successful landing. They crash landed on the moon after a series of mishaps that happened just before landing occurred. And now it's been a week, and the Space IL team has spent this past week investigating what exactly happened during the landing sequence. If you were watching, what we knew at the time was that a few minutes before landing was supposed to occur, the main engine shut off, which is not a good thing. They got it back online. They had issues with their telemetry because of the main engine shut off. They lost communication, and then they realized that it wasn't coming back. And now what appears to have happened was before the main engine shut off, a minute or two before that, there was a reported issue with one of the inertial measuring instruments, something that measures the inertia of the spacecraft and figures out how fast it's going, where it's going, and things like that. And someone on the team entered a manual command to try and fix that issue, which somehow led to that cascade of issues, starting with the main engine failure. So there was an element of
Bummer
human.
for that person.
Yeah. they're obviously not releasing the person's name, obviously. But it looks like the issue started even before the main engine cut off, and the main engine cut off was in fact a symptom of trying to fix an earlier error during the landing sequence. The investigation's ongoing to figure out why the issue with the inertia instrument happened, what command it was that caused an issue. Maybe there was a programming bug somewhere that caused this cascade of issues. So they're still looking into what's happening. They did, okay, fair enough. They did actually put the first commercial craft on the moon. Not the way they intended,
Yes.
but it's there. All of the team members who were live on camera while this was going on wanted to emphasize that it's on the moon.
Yeah.
We put it there. Just it's not exactly how we had planned.
That looked like most of my Kerbal Space Program landings.
Yeah. And they are going to try again.
Yeah.
Is what the word is. They're going to do Bereshit 2 after they figure out what happened with this one. The same Israeli millionaire who donated a lot of money to this program has already pledged money to the follow-up program for the second attempt. And I mean, we'll keep learning about what happened as this goes on, and hopefully they'll try and figure it out and put together another little lander for the moon.
Yeah.
So the big takeaway here is that redundancy is good, and they didn't use any redundant components, I think, anywhere on the spacecraft, because the launch was sort of a ride along with another launch as part of the Falcon 9, and so they were very, very constrained on the amount of weight that they could include, and of course, including twice as many instruments and things costs more money as well. And so they were operating in sort of single point of failure mode. And this is why NASA doesn't work in this way. And this is why NASA missions cost a lot of money and take a long time to build, is because they have double or more redundancy in components. And we might bemoan the times that missions get over budget or run long, but it's that extra layer of protection that means that almost all NASA missions or ESA missions or JAXA missions basically work.
Yeah.
And it's because we learned in the 60s and in the 50s that you have to have this redundancy. Mm-hmm. And private companies and private organizations will start to figure that out, that it sometimes it's worth taking the chance and sometimes it's not.
I mean, as we start to think about the Moon 2024 plans, just remember this. Right? To go fast means safety is what takes the back seat. And if you want to go fast with human beings on board, then it is a potentially catastrophic situation. I mean, this was just a robot. It was a learning experience for everyone. They could have made it.
Yeah, and it really was a learning experience, I think, for the Space IL team. I mean, they did this homegrown moon lander. It made it to the moon exactly when they thought it was going to get there. They had some issues, but they will, like the thorough investigation that they're doing, all of that information is going to go into the next attempt. They had an incredible outreach and advertising campaign to get the word out about what they were doing, which was very successful. They're going to draw in a lot of new talent from that. Their team already knows what to do and what not to do.
Yeah. To
do it again. So
they deserve all the credit in the world for.
They do. I mean, they really did do an incredible mission. And I imagine in the next couple of years we'll be hearing from them again, when they try again.
And I think like amateur astronomers everywhere are sort of happy with this valiant attempt to at least try to destroy the moon, right? It's one way to start. Once a month we can't use our telescopes, so it'll be all right.
It's all good.
Yeah.
Lunar Reconnaissance Orbiter is going to try and pinpoint where it is. Going to see if that retroreflector is still working. Maybe they still get some science out of it. We're going to see. It might just be a crater. Who knows? We'll see, hopefully, from LRO in the next couple weeks.
All right, Morgan, why don't you tell us the bad news? Weird news?
Yeah, I guess it's good in the end. This is the part of the show where I try not to swear.
Yeah.
So our good friends over at Futurism broke a story this past week that a Russian company called Start Rocket had performed a test of a satellite. This test was not into orbit. It was a stratospheric balloon test. But they performed a test of a satellite that was planned to go into orbit and serve as a billboard. So that as it orbited in low Earth orbit every 90 or so minutes, this billboard would pass overhead and be visible from basically everywhere on Earth. And they touted in the press release announcing this test that they'd signed their very first client, none other than Pepsi, or at least the Russian subsidiary of Pepsi. And the good news is that after sort of the fury of the world fell down on their shoulders, that they at least Pepsi has backpedaled from this idea. The bad news is that somebody's going to do this.
Yes.
We get up here every week and we talk about how amazing it is that we're lowering the cost and the barrier of entry to space with things like reusable rockets and common components between different spacecraft. And all of that is true. But sort of the problem with lowering the barrier to entry is that you lose a filter of sort of good of quality to your ideas. And we've all experienced this like on the internet, right? It used to be that only you had to put a certain amount of effort in to make a website or an app or something like that. And then as those barriers have started to fall, we get more and more dumb stuff. And all it takes is like one place on Earth willing to let people launch these dumb things to basically make it impossible to stop this. And so it's time to figure out as a sort of world society how we're going to deal with these things. Are we going to sanction the countries that allow this to happen? Are we going to shoot down their satellites? Are we going to just sort of wish it away? Because Start Rocket may never launch. If Pepsi was really kind of their bankroll, they might be in trouble now. But somebody someday is going to be able to do what Space IL did and be a private group of people who gets some money together, gets one of these tiny little rocket companies to launch something into space for them. And we're all going to have to look at it.
Yeah.
And
so maybe
we're going to turn our planet into a Dyson sphere.
Right.
With billboards in our faces.
So maybe that's what India was testing a couple of weeks ago.
Shooting down billboards?
Shooting
That's not
down
a bad
space
plan.
billboards. I know. So we were all questioning their ethics, and now we hear with these plans, India has got our back. So
we talked about this like a year ago when somebody was going to launch that star thing into orbit. It was like a big disco ball.
Yeah, they launched it. It happened.
They did launch the disco ball.
Yeah.
Yeah. The thing with the disco ball is that there's no real financial incentive to do it. The trouble with ads is that there is, at least in principle, a financial incentive. Yeah. And if there wasn't, we wouldn't have to drive past billboards.
Yeah.
And if you live somewhere on Earth that doesn't have billboards, then good for you. I hope your country comes to rule the world. And then we don't have to worry about this.
Yeah.
But the reality is that someone's going to do it, and it's going to suck.
Yeah. This is a nightmare.
So don't do it.
Don't do it.
You hear me, Pepsi?
They
said, watching?
They said they never planned to do it.
Yeah, that's BS.
Well,
kudos to Futurism for following up on them and calling them on their crap, because I don't buy that this wasn't an idea that somebody approved somewhere.
Yeah, they did. So you should definitely read the story over at Futurism. They absolutely nailed this one and got the scoop on all of us. And we've just been directing people their way to let them get all of the boon from their scoop. All right, I'm going to do one quick story, which was last week. Of course, we were talking about the madness of what a space week it was. We talked about the black hole. We talked about Beresheet was about to land. And we talked about the Falcon Heavy that was about to launch It was originally supposed to launch on Thursday, and this was going to be the second launch of a Falcon Heavy, this time with a commercial payload. It was going to be carrying an Arabsat satellite to a geosynchronous transfer orbit, about a 6,000 kilogram satellite. So possible to be carried on a reusable Falcon 9, but they put it on a Falcon Heavy. And it was scrubbed on the Thursday because of high winds, and then it ended up flying on the Friday, and it was an absolutely beautiful launch. We watched it on the big TV here, just moment after moment. I'll put parts of it here so people can see. Of course, they had really improved the footage. You could see here. I'll let my
I loved all the multi-camera views as it split apart.
Yeah, so you could see the sort of the perspective of all the different parts of the rocket, and then as the two boosters separated away from the side, you could sort of, they had their own separate view, and it's sort of in synchronicity.
It's like movie staging.
Yeah, now you're gonna get the deniers, the conspiracy theorists. So they came back to Earth perfectly, just side by side. It was absolutely amazing to see this, and of course, they did that classic side by side landing down at down at Cape Canaveral. Let me see if I can get the moment where that happened. And the big question, of course, was, would the center core land? And of course, with the previous one, the landing had failed with the center core. It had just smashed, it just missed the side of the barge, crashed in the ocean, and so they weren't able to recover the central core. This time, we
love that landing.
Yeah, it's beautiful.
Every time. What?
Yeah, so we
I'm
saw
agreeing. Yeah, that's amazing.
the preparation for the landing. Everything came in perfectly, and then here it comes, and then the video feed cut, which is not too surprising because the whole the drone ship gets shaken quite a bit. And so we're like, did it land? Did it land? And then when the video came back, there it was, the central core, safe and sound on the barge. The update, of course, that we learned over the weekend was, in fact, it wasn't safe and sound. The
Kerplunk.
Sploosh. So it was in heavy seas, 6 to 10 foot seas, and the booster at some point fell over into the water, and they weren't able to. Now, I haven't been able to piece back whether they lost it entirely, or whether they were able to bring it back but broken or soggy. But the reason, as I understand it, was that the capture mechanism that they used for this didn't fit for this core. They have this thing called the octograbber, and it's supposed to grab these boosters as they land on the barge, on the drone ship. I can't call it a barge.
Elon's really playing into the Bond villain stereotype with the octograbber.
Yeah, it's a great name. So I have to.
Is that what he wanted to be when he grew up?
I have to
a Bond villain?
Probably. He's on his way. So I have to change the article that we did on Universe Today because we had said it was perfect. Perfect launch, landing, everything went flawless. Turns out not quite flawless, which means the next time a Falcon Heavy launches, we will hopefully, that'll be the chance for everything to come together. But still...
They need a bigger boat.
We're going to need a bigger boat. It was absolutely fantastic, though. It was some of the most compelling footage. Like, if there's one thing SpaceX has just gotten amazing at, it is covering their launches from beginning to end. There's even some shots you could see of the fuel floating inside, in weightlessness inside the upper stage. Just amazing stuff. So,
I mean, that's super awesome.
Yeah.
It's also a bit excessive.
No, are you kidding? What? I want a separate camera because it looks like this amazing floating liquid oxygen blob. Wonderful.
Whatever.
Yeah.
It's really cool.
Yeah. So anyway, it was you could see again with the challenge, right? This your liquid fuel turns into this weird mass inside your rocket that you have to account for as you start to increase the thrust again. So anyway, it was wonderful. Congratulations to everyone at SpaceX. Sorry about your central core. Better luck next time. Keep trying. You'll get it. All right.
It's the message of this week. Keep trying.
Yeah, exactly. Kimberly, you got one last story?
Yeah, I want to do a quick exoplanet update because I haven't done one of those in a while. We joke all the time about how exoplanets are a dime a dozen nowadays, and every day we're finding a new one, and none of them are really particularly exciting. A few of them are actually pretty exciting, and 2 of them happened this week. So quick updates. The first one is that the Transiting Exoplanet Survey Satellite, or TESS, discovered its first Earth-sized planet. Yay! Also, congratulations to TESS. It launched 1 year ago tomorrow. Yay! And it found its first Earth-sized planet. It's actually smaller than Earth, about 90% the size of Earth, around a star that's also about 90% the size of the sun. This planet is in no way habitable. It's way too hot. It's in a system with another planet a little bit smaller than Neptune, and they're gonna try and get masses for both these planets to see whether this smaller than Earth planet is actually made of rock or not. So cool. Go Tess. Keep going. It's doing awesome stuff already in the first year. The second exoplanet update I have is a really cool one about a circumbinary planetary system where it already has 2 planets. It was already known to have 2 planets going around 2 central stars, each of which are slightly smaller than the sun. And recently, this star system was discovered to have a 3rd planet in an outer orbit, which makes actually this planetary system what they call dynamically full, which means you can't fit any more planets in this system without knocking everything out of whack, which is a thing that was predicted for this system's Kepler-47. They predicted this planet would be there based on one transit they saw in Kepler. They got a second transit with a different telescope and then went back into the Kepler data to find all the other ones and tease them out of the noise. So this is a really interesting discovery because it shows that all of these dynamically packed low mass systems are actually really common in the galaxy. And here is another one. It's around a circumbinary binary star, circumbinary planets. It's talking too fast right now. Anyway, it's a very cool discovery. Exoplanet.
Exoplanet.
Yeah.
Still interesting
Closing.
after all these years.
Sometimes they're still cool, even though we see a lot of them.
Yeah. Arnstro was saying that sounds like a job for Universe Sandbox. I'd love to see that. Because they weren't the same size, right? One planet, one star was
one star is a main sequence star. It's a little bit smaller than the sun. The other one is much smaller.
Yeah.
And
then the planets orbit them both?
All 3 of the planets orbit both of the stars at the same time.
Right.
So the 2 stars are in a very tight orbit. The 2 stars orbit each other in only I think 7 days or something like that, which is usually the orbits we're talking about with planets. But no, these are 2 stars going around each other super fast. And then the planets are in much wider orbits of 30, 50, 300 days type of thing.
But isn't it funny that we're now at that point where only really interesting planets get reported on now?
It's true.
Yeah, here we are. Great time to be alive.
Keep chugging away, Tess.
Well, we've got you on screen. Kimberly, why don't you tell us something interesting that you're working on?
Ooh, so while our special guest was talking about drilling cores on Mars, it reminded me that I was just working on an article about drilling cores in the Atacama Desert, which is one of the places on Earth that we use to simulate what it would be like to be on Mars. So I was looking into what kind of wet periods the Atacama Desert, or the driest place on Earth, has had in the past few 100,000 years. So you can read about that soon on eos.org.
Morgan.
Last year, you might remember me talking a bunch about working on crash course engineering. And after dozens of episodes, the last couple are trickling out in the next week or so. And some of these last ones are some of the favorites. I particularly liked one that dropped last week that is all about signal processing and telecommunications. It's a tricky subject that I thought we did pretty well on. So if you haven't had a chance to go check some of those out, I learned a lot about engineering. It turns out engineers are pretty darn cool. And I hope that you think so too.
I just have a bunch of really bad memories about taking engineering. So I look forward to watching this horror movie series that you've created. All right. I have nothing interesting to add. We sort of collapsed after putting the black hole story video out, I think after the Weekly Space Hangout last week. So if you haven't watched that, we did a video all about the black hole last week. Check that out on my YouTube channel. And apart from that, it's been a crazy week. This week was a lot simpler. I had a little. So far, it's been chill. It's been good. All right, let me put us all up on the screen. There we all are. Huge thank you, of course, to our special guest, Dr. Dorothy Oehler, for explaining Mars methane to us. That was great.
Good timing.
Yeah, I know. Kudos to Nancy and the team at the Weekly Space Hangout for bringing guests who are perfectly timed to some of these really big stories, especially the twin story that is coming up. You guys are just absolutely crushing it, and we really appreciate having you as partners. And of course, if you want to be part of this team, go to wshcrew.space. You can participate in the chat. Now I have to sort of point through Morgan's head and down to the chat. You will. But you also get to be an executive producer of the show and help make it better and help choose the guests. So be a part of that. wshcrew.space. And thanks to everyone watching, and thanks to all our moderators. We will see all of you next week. Thanks, everybody. Let me find the stop button. There it is.